A very good morning, class 10th. In today's topic, we'll be doing ester hydrolysis. Now, what does this word hydrolysis mean? The simple meaning of the word hydrolysis is add water. Now, when you want to add water, water is not considered as a reactive identity. So, it can either be in the presence of acid that you're going to add water, called as acidic hydrolysis, or it could be in the presence of a base that you're going to add water. That is called as basic hydrolysis. Whatever the case may be, the addition is only of water. So when you write dilute HCl, that means you're adding water. You write dilute sulfuric acid. Again, it has water and that's the addition. Or at times it is found that it's written like this on the arrow, or it is written like this in the arrow. Whatever may be the reagent on your ester. So if your ester is made to react with any one of these, it means nothing but addition of water. And when you add water, your ester breaks. Now, what are the components of an ester? If you remember, how did we prepare an ester? To prepare an ester, you required two identities. One was carboxylic acid and the other was alcohol. And if you remember, we had added concentrated sulfuric acid to the mixture, and the function of this concentrated sulfuric acid was to remove water. This concentrated sulfuric acid is your catalyst in the reaction as well as your dehydrating agent, that is to remove water. Whatever the situation, you end up in an ester after carboxylic acid or alcohol loses water together. Now, in case I'm talking about hydrolysis, when I talk about hydrolysis, it is gain of water. Now, if you want the ester to gain back the water that was lost, it's quite evident that the products would be carboxylic acid plus alcohol. And the same carboxylic acid is regenerated and the same alcohol is regenerated back. So the concept is ester hydrolysis is nothing but gain of water onto the ester to give you back its components, to break down to give you two components which are carboxylic acid plus alcohol. That is the base of the reaction that we are going to do today. Now let's take the method. I'll be doing acidic hydrolysis first. Now let's take an ester. This is my ester, RCOOR. Now to this ester, I would be adding the acid. Now when you add the acid, your interest is, acid means H positive and it would be in a solution, so it also has water. And it is water that your interest is in, and it is the water which would be added on. In the ester, when you add water, this is how it responds. This breaks down. You get an H here, giving you back your carboxylic acid, RCOOH, and you get an OH here, giving you the alcohol back. So your water adds on to the ester to give you back the carboxylic acid along with the alcohol. This is exactly how the reaction happens. Now, in case you are given like this, or it is written as dilute HCl or dilute sulfuric acid, whatever the situation, your product is going to be same. Now, let's try out a specific example of an ester to understand the acidic hydrolysis a little better. The ester that I am taking is ethyl ethanoate. Now, what is an ethyl ethanoate? When we talk about ethyl ethanoate, it's an ester. Ester is like this. The part which is as a prefix is the side of oxygen. Ethyl means there are two carbons here. Fine. The suffix part comes from the carbon side. It's written ethanoate, which means total number of carbons is 2. One you already have, one more to go is the compound that is given here. Sorry, there has to be a CH3. Ethyl ethanoate is the compound. Now when you make it undergo hydrolysis, that is I add dilute HCl to it, or I write it as H3O positive. Whatever may be the case, it would result in cleavage of your ester. Here you give an H to give you carboxylic acid. Here you give an OH to give you the respective alcohol. So your product is CH3COOH plus CH3CH2OH is your alcohol, which is the carboxylic acid, 2-carbon carboxylic acid. So ethanoic acid and 2-carbon alcohol, so ethanol. So that was your ester prepared from ethanoic acid to ethanol. Now in case you want to prepare the ester, then what do? You take the reaction forward direction, write concentrated sulfuric acid, which will help you remove water. And if you go forward direction, you want hydrolysis. So if you have an ester and it is to be prepared from carboxylic acid plus alcohol, that is called as esterification, concentrated sulfuric acid, but that is the esterification reaction. Now if you have an ester and you hydrolyze it, that is by adding acid in the presence of water, then you would end up in hydrolysis, which will cleave your ester to give you back the carboxylic acid and the alcohol with which you had started it off. I'll take one more example of ester hydrolysis to create the clear concept. The second example that I'm going to take is methyl propanoate. Methyl propanoate. Now when I write methyl propanoate, means it's an ester. Methyl is the oxygen part, so I have CH3 here. Propanoate is the carbon part, total carbons 3. One you already have, 2 more to go. So that's the structure of methyl propanoate. And if you are making it undergo hydrolysis, I write dilute acid or I write H plus aqueous. That's up to you. When you add water to it in the presence of an acid, this cleaves, you get an H here, give an OH here, you end up into CH3, CH2, COOH, the carboxylic acid, which is propanoic acid. And you end up in an alcohol of 1 carbon, which is methanol. Fine. That is how you proceed when you talk about hydrolysis or an acidic hydrolysis of an ester or cleavage of an ester. Now, coming to the second part, I also said it could be a basic hydrolysis, which means you are going to add water in the presence of a base. Example of a base which is water soluble, NaOH or KOH aqueous are the reagents that are required by you. This is also called as alkaline because bases which are water soluble are alkali in nature. It is said to be alkaline hydrolysis of ester. So again, in this bit, I am taking a general ester first and then we will do one specific example. This is your generalized ester. Now, to this you would be adding NaOH because you are breaking it in the presence of a base. Now, when you add NaOH, this is what happens. Here you get an Na and here you get an OH. So now your product on this side is the alcohol, which was originally also there. The oxygen part gives you the alcohol. But on the acid part, you do not get an acid because the acid, if formed, your RCOOH, if formed, will react with your base to give you a sodium salt. So your acid which was formed combines with the base to give you the sodium salt of acid. One more specific reaction under this category. CH3, CH2, COO CH3. That's the ester that I've taken. Let's give it a name first. Oxygen side first, 1 carbon, methyl. Carbon side after that, 3 carbons, propanoate. NaOH aqueous. On adding NaOH aqueous, this ester would break. You would get Na on this side, OH on this side, giving you the products as CH3, CH2, COO with an Na plus CH3OH. That's your methanol. And you also have a sodium salt of propanoic acid. Now, this particular reaction, the alkaline hydrolysis of an ester, is also called as saponification reaction. Why so? Because if your R group is large or bulky, that is, it has carbon 15 and above. If the R group is that big, then it is this particular R group is that big, then your R group here would be large and it would be a sodium salt of an acid which has a large number of carbons. And such a carboxylic acid which has a large number of carbons is called as fatty acid. So your product in that case, if the R group is a bulkier R group, the product would be sodium salt of fatty acid. And this is nothing but soap. That's why the name of the reaction is saponification if your ester is made to undergo hydrolysis in the presence of a base, so that the sodium salt of carboxylic acid that you get is the other name of a soap, only if the R group is large. So by definition, saponification is preparation of soap. And if you are asking what is a soap, soap is nothing but RCOONA, where this is a bulkier group. So that's the general formula of a soap, and where this is the compound with R group should be large. That is, should have carbon 15 or above. Fine. So that was saponification. With this, I close my class on esters. That is your hydrolysis of an ester, or you could call the class as saponification. That's preparation of soap. Thank you. Bless you all.